Cool. So what an absolute pleasure it is to be at my second MagentoLive UK. So today I'm going to go through what I call the deconstructed Magento module. So there's a little bit of information about me. I'm James, technical team lead in Vika, formerly Session Digital. The companies merged earlier this month. And if you want to get in touch after the presentation, you can find me on Twitter @jcowie or GitHub James Cowie. So when we talk about deconstruction, what do we actually mean? Well, in the physical world, when we say that we're going to deconstruct something, we say that we're going to take it apart to reveal the insides, its composition, what makes up an object. And that's quite interesting when I started to think about what we actually mean when we talk about a decomposed module or a decomposed piece of software. And it's quite hard to think in terms of the real world when we're talking about virtual software. So how do we actually take apart a class? How do we decompose our system? How can we work out what its biases are, what made it, what are its composites? And while I was working through this notion of decomposed software, I came across the law of Demeter, which instantly got me excited because I thought it was one of the original wrestling groups, LOD, Legion of Doom, but it wasn't quite as exciting. And the law of Demeter is actually the principle of least knowledge, and it's a design guideline for developing software, particularly object-oriented programs. And in its general form, it tries to promote loose coupling. What it really means is don't talk to strangers. So if you've got class A, then it shouldn't really talk to anyone that it doesn't need to know about. So that's great, that's deconstruction. We've got a principle that will allow us to start writing decomposed or deconstructed software if we follow the law of Demeter. But what is decoupled code? So if you go around and research what decoupled code is, it talks about tight coupling. So the Wikipedia definition of tight coupling is when a group of classes are highly dependent on one another. The scenario arises when a class assumes too many responsibilities or when one concern is spread over many classes rather than having its own class. Sort of like Mage.php in Magento 1, a ginormous God class that does far too much. So every single line of code in Mage.php is pretty tightly coupled to the framework itself. We couldn't take out some of the functions and expect to use them in another project. So we know what tight coupling is. What is loose coupling? What if we flip it on its head, what do we actually see? And loose coupled code is where each system's module has or makes little use or knowledge of each other. So it's a load of individual classes spread across the system, only talking to the classes that they need to know about, just exposing a public interface, an API that they can communicate via. And we also got this notion of cohesion. So we talk about high cohesion in software. And in the software that we write. And a module that's got high cohesion is preferred. We all prefer to have a module of high cohesion because it's got several desirable traits: robustness, reliability, reusability, and understandability. So if we find a class that we know and trust, easy to use, easy to understand, we tend to say that that's got a high level of cohesion. We understand it quite well. Whereas on the contrast, low cohesion is where it's quite difficult to understand. It's got very undesirable traits, such as being hard to test, hard to reuse, and really hard to understand. So some of the classes in the original Zend 1 framework really have got low cohesion. The Magento class is really difficult to actually understand. We probably wouldn't want to test it. We probably wouldn't want to go anywhere near it. So that's what we talk about when we say a class has got low cohesion. And we can try and move away from high coupling and low cohesion by using some principles, the dry principle, that don't repeat yourself. If we write a single piece of code well and make it reusable, then instead of sharing that exact functionality by copying and pasting, we can create it as an own module that we can share between our applications. We can use the PHP language of traits. Traits were introduced in one of the PHP 5.x versions and allowed us an easier way to share reusable code inside of the PHP language. We can use composition. So in the days of Magento 1's birth, it favored abstraction over composition. We had abstract classes that we had to rely on. But now we've come to learn that composition is actually far more desirable. We can see what classes are our module is composed from, we can actually see how we can make a module using all this functionality because it's composed by all these individual units of code. And we also leverage interfaces. Interfaces become our public API. We say that this class of person has got legs, bodies, and eyes. They're its interface, its blueprint, that we can share that knowledge throughout the application itself with. So that's the boring bit, the theory part of this presentation over and done with. So now some real-life example code that we can use in Magento 2, which is actually going to showcase a naked module and a deconstructed module. So what we're going to actually build is a Magento 2 CLI command, which is going to email the store admin. And we're actually going to use Mandrill, because Mandrill never changes. It's never changed its pricing, ever. So while I was prepping for this, I went away, beavered frantically in my man cave, and built this horrendous mess of code. Don't worry, I couldn't read it anymore either. And my eyes still burn looking at that code. But that was the first case. So if we break it down a little bit, in Magento 2, to have a command line argument or a Magento 2 command, we use the Symfony components, so we can run bin Magento, and this is where we add to it. So we create a simple command that extends command, and it's got two default functions, configure and execute. Inside of our execute command, function, we create a new instance of Mandrill, pass it in our API key, and then build a message of parameters that need to be sent over. We then commit a bit of a sin in Magento 2 land by relying on the object manager directly, but that pulls me out the product collection so I can filter through all the products that I want, loop over them, assign them to a string, and then finally set up some template variables and send the email off. And then finally write to the console and say, email sent for the out-of-stock products. And just like my primary school and high school teachers said, I must try harder. So, for anyone that didn't see some of the errors in my ways there, all of the logic was enclosed inside of a single method. Inside of the execute method, I did all that work. And that's quite a lot of information to keep in your head at any one time. And for me to pass that on to any one of my co-workers or open source, they're going to look at that and wonder, like, I'm not a Mandrill expert, so what are all these variables doing? Are they part of my code? Is it part of Mandrill code? There's no reuse. So I'm going to bet that email in the application is going to be used in more than just my out-of-stock module. So I've pretty much hard-coded all of the Mandrill configuration in a single place. So there's no reuse. Anytime somebody else wants to use Mandrill in my Magento application, they're going to have to reinitialize it, set up a new API key, go through all the process that I've just done in the single method. Hard to understand, and it's actually pretty hard to change. It's expecting people to be a master of Mandrill and a master of my Magento 2 command. So it's going to become that place where people don't really want to change it that much, especially if there's an error. And the issues that come with the class itself are that it's very fragile. If Mandrill's API changed, it's going to break the class. And that increases the cost of change. So when my manager comes to me and says, can you add an extra field to that email that we send out for the out of stock? Instead of it taking a few minutes to change, I'm already worried about the implementation, how hard it is to change. So the cost is increasing in time and value to the end user. And I've inherited some technical debt. It's all in a single, unusable, unreusable piece of code. So the technical debt's there that's going to have to be repaid. And when I say it's fragile in the sense that I've got no tests. How can I prove that this piece of code works? I can't unless I run the code. By running the code, I'm going to send emails. I'm taking up CPU time and my time. I've mixed business logic with the framework. So instantly, that class now requires a Magento 2 developer to understand what it actually does. They need to know that the execute method can be found within a command class. And the cost of change is, again, because email is going to be used throughout the application itself. Mandrill isn't a one-off implementation. We want to use it again and again. Very hard to understand, especially if that class grows in order of magnitude. And I bet every single one of you developers has got that class that they don't want to touch. And that's what it becomes. And over time, there's more of those classes that you want to try and stay away from. Again, technical debt is the impact that we've got. How fast can we change? How can we be agile, adaptive, and modify the pieces of code that we're actually building? So let's break down what the method is actually doing to see if we can try and make this class a little bit better, see if we can deconstruct it a little bit. So we know that it's building variables, it's setting up these template variables that we need to get sent out. It's getting all the products from the collection out of the object manager, and it sends the email, it fires it off somewhere. So let's start refactoring. Let's go through some of the code, make it a little bit cleaner. Let's abstract out where we can. So we start off with our email command, and the way I see it, 3 responsibilities, maybe. So we've got a model for the emailer, we've got a model that will get me out of stock products, and we've got the actual command, the bit that glues it all together. So we can see that the model emailer and the model out of stock, maybe a bit of framework, definitely emailer isn't going to be specific to the framework. But out of stock, he's going to start to know about Magento 2's collections a little bit more. Maybe, maybe not. And the emailer command definitely is going to. So we build the model for the emailer, and we pretty much just lift and shift the code from the big horrendous mess that you all saw. So we've got a single class that doesn't extend from any other classes. All it's doing is what the Mandrill API specifies. So set template and send email. No point in there is there any Magento 2 framework code. In fact, it's pretty much just plain old PHP objects that does make it quite easy to test. We don't have to start mocking dependency after dependency. It's a plain old PHP object. For the out of stock products, again, this time our class just is the out of stock products. So maybe we can inject into it the data that we want to loop over. So we pass into this class all of the products and say, just get me out of this array. What products are out of stock? And the emailer command then comes quite a little bit smaller. So inside of our execute command, we're still going to create a new instance of the emailer out of stock, and we're going to still create a new instance of the emailer, but instead of it being a ginormous, horrible mess of about 80 lines of code, we've now got 2 classes, and we're down to 5 lines of code that just set up the bare minimum to actually send an email in the command. Starting to get a little bit better. It's probably a little bit more maintainable. I still haven't got any tests, but if I wanted to test the 2 plain old PHP objects using PHP spec or PHP unit, it's probably a lot easier. I don't have to mock as many things. I don't have to worry about it touching the database. And my integration test is probably going to be a lot easier now just by testing that the output of the command line is going to be there. So I've got separate classes, easier to test. I'm pretty sure that anyone would say that it's a little bit easier to understand now. If you want to know where the out of stock email gets sent from, you're going to go to the out of stock class. Just PHP Storm's going to pop up when we start typing out of stock and it'll find it. And we've moved away from the framework. We're not expecting people now to be Magento 2 experts. We're expecting them to be experts in their field. They know about PHP. So move as much as it out away from the framework as we can. But again, if we could just do it a little bit better, that'd still be great. So let's go all out. Let's take the gloves off, and we're going to go for attempt number 3, where we're going to use interfaces and we're going to use dependency injection. So we start off by creating an interface. And if anyone spent any time with Magento 2, an interface is a service contract. So think service contract is an interface is a service contract. And all this interface is our public API for our application. So anytime that anyone wants to create their own emailer, they implement my emailer interface, my blueprint for anyone sending email, and they have to implement their own send and set variables functions. And interfaces are important because it's a contract for other developers to follow. If we actually start implementing interfaces in our code as module vendors, it means that no more do we have to worry as merchants, as developers, about extending their internals, their core. So if Magento 2's customer object, the low-level implementation changes, but we've implemented an interface, as long as their interface doesn't change, which it shouldn't because they're using semantic versioning, then we're okay. If we start relying on the concrete implementation, the actual repositories, the core classes, then we're opening ourselves up for for breaking changes. But because we implement the interface where they're saying, look guys, this is my public API, use me as you will, then we're reducing that risk. We're aiding in testing, so it's far easier to mock an interface because it hasn't got any physical dependencies. It doesn't talk to a database, it's a blueprint for us to work from. And by working with semantic versioning, we should be limiting our backwards compatibility breaks. We know that the APIs can be versioned by semantic version. 2.1.0 will be this interface. If we break the interface, then we move up a major version. If it's just bug fixing and we don't affect the interface, then it's the last number, the final digit that actually increases. And we can leverage PHP's type-safe checking, so we can make sure that this class actually is an instance of emailer. So we can leverage some type checking there. And we're starting to get into solid principles now. So by creating interfaces, we're starting to think more about solid. So solid comes in the single responsibility principle, the open-close principle, the Liskov substitution principle, interface segregation principle, and dependency inversion principle, all outlined by Mr. Uncle Bob. But the one I'm interested in at the moment is the open-close principle, which states that simply a class should easily be extendable without modifying the class itself. So if I want to add a logger instance to my emailer class, then I don't have to open the emailer class to add my line. I should be able to modify its behavior without actually touching the core implementation. And we can do that by implementing our interfaces a lot easier. So we're going to create a mandrill interface, or a mandrill implementation that implements our interface. So we create a class of mandrill, we implement our emailer interface, and we go across and implement our own set variable and our send. So they're mandrill specific functions in there that adhere to our blueprint. We go back to our command class, which is the Magento 2 framework, the glue that takes our non-PHP, our non-Magento 2, and puts it into Magento 2. And inside the constructor, we use our types check, and we inject an instance of the emailer interface, and we pass in again an instance of the out-of-stock product, assign them to 2 variables that can be used in the class. And I know what I was thinking when I went through this example when I was learning Magento 2. Injecting an interface. It's like, wow, that's crazy talk. It's going to throw errors all over the place. But that's how Magento 2's dependency injection works. And most dependency injection can understand a concrete implementation and map it to its actual implementation. So if we skip that we've injected an interface for the time being and just go with the flow, we go into our actual execute command, and here we're just saying this emailer set variables, we're calling the private objects on the 2 classes that we've passed in, and we're pretty much just sending the email. 2 lines of code from what was 80 lines of code setting everything up, because it's all been delegated to its individual classes. And this is where the XML comes in. So Magento 2's got its di.xml, and this is where I can say to Magento, anytime you see a request for emailer interface, replace it with this class. So it uses the config node, Magento 2, all of its di.xml is nested within config. And it says, this is my preference. So my preference for emailer interface is always going to be mandrill. So just by having that single XML file, I can code to interfaces and inject the concrete implementation, which is really powerful within our code. We can swap things out ad hoc. If we decide that we don't want to use maybe this mandrill, because of the di.xml, we've got a single place which powers all of our further implementations of email, customer, database, etc., whatever we might need. And this is the D of solid, so the dependency inversion principle. It states that entities must depend on abstractions, not on concretes. It states that the high-level module must not depend on the low-level module, but they should depend on abstractions. So our class adheres to that because it's depending on the abstraction, the interface itself. It's not actually depending on my actual mandrill class. It's saying depend on my interface, my blueprint for how email should work. So we're all sat there Monday morning in our offices, all hell breaks loose. Mandrill, would you believe it, are now charging. So our manager comes up to us and says, we need to change it. It's all within MailChimp, quickly get it changed. So you get a brew. You think, all right, I'm going to find and replace in my project, which is the way that we'd normally go about it. If we wanted to change an entire implementation of emailer across our application, it's find any time that we're calling new emailer, swap that out, pray that we've not broken anywhere. But in Magento 2, it's easier. We create a new emailer client and we update our di.xml. Our application will continue to work just by creating one file and modifying one di.xml. Boom. Like, considering you've not made any new emailers, then that's unfortunately your own fault. So we do that by creating a PHP client. This is just going to implement basic PHP send mail command. So we implement the emailer interface, which is really important because we're always going to depend on abstractions, not concrete implementations. So send just returns mail, blah-de-blah. Set variables, populates the basics. It's not going to be a nice mandrill sent template. It's just going to be plain old PHP. And again, we update our di.xml. So instead of the preference being for the mandrill interface, it's going to say, right, my preference for emailer is now the PHP client. And instantly, anytime the emailer interface is called, it's going to be replaced by the PHP client. And because I'm implementing send and set variables, the application continues to work. Now, why should we do this? It's probably quite a lot more effort. Well, it is quite a lot more effort. First, to go through adding the di.xml is increased learning, knowledge that has to be done. Our actual IDEs are going to have to be reconfigured to understand how it can map from interface to concrete implementation. But the benefits far outweigh those tiny negatives. Each class does a single thing well. My emailer class does one thing well. It sets variables, but it does email. It does email very well. My actual get out of stock products just returns me out of stock products. It doesn't write to a log file. It doesn't check to see if today's Tuesday and the product's still out of stock. It gets out of stock products. Each class is easier to test because they're not extending from the framework themselves. They're plain old PHP objects, which I know email is quite a primitive example, but this can scale up exponentially. We can start thinking about the individual items that our applications need to do, their specific domains, and we can create plain old PHP objects that represent the domains. So we're not having to mock X, Y, and Z. We're not having to mock the object manager, our repositories. We're just mocking a PHP object and the variables inside of it that we know that are needed to operate. We're using interfaces, and the interfaces enforce a common public API. So any vendor should really be implementing their own interfaces. But the benefit for me is that I can give you my emailer client, put it out there in the open source realm. I'm implementing, or I've said this is my blueprint. You can build any PHP mailer you want, but you have to implement these two methods. And you can go away and build whatever you want, add it to the open source community. And as long as you don't rely on my low-level implementation doing something because you're relying on the two methods in the interface, then we're never going to break. And using Magento 2's di.xml, it actually allows dependencies to be mocked and made visible. Instead of us wondering what is our module composed of, what is our class composed of, going through and checking to see whether we did the mage get X, mage get Y in Magento 1, or are we instantiating new objects to see what our classes actually do. We look in the constructor and we can see, wow, this class is doing quite a lot. Maybe its responsibilities are far too spread. Do we refactor? Do we make this class smaller? Can we look for patterns? Can we move it around? And DI has exposed that visibility of classes doing too much for us. And where else can we see this in play then? So this is just a simple module that I decided to build for the presentations. But you can see this exact same functionality going on inside of the Magento 2 core. You can find it in a technique known as hexagonal architecture. The Symfony realm is quite big on hexagonal architecture, creating ports and docs where you're linking containers and objects responsibilities together in plain old PHP fashion. And domain-driven design sort of pushes us towards this way of thinking, creating bounded context, representing our objects with domain-specific models So even though it's not an actual implementation, it's a way of thinking about objects, how they live, how they represent in the real life, and how they can be single, isolated entities. A little bit of a disclaimer though, not all Magento 2 core implement service contracts yet. So I know they are working towards that. So there is quite a lot of the core covered with service contracts. And if you find a service contract, use it. An example being customer. Customer class is, I believe at last time of checking, probably the most complete Magento 2 module out there. So it's got its own interface for interacting with a customer. So set ID, get all the group stuff. We should rely on the interface. And that's because inside of the customer's di.xml, it's got its own preference. It says that anytime any part of the Magento 2 application calls customer interface, send them the data customer object back. So Magento 2's checking out itself these interfaces that are being requested and passing us over a concrete implementation back, as long as we use the customer interface. If we didn't use the customer interface and we relied solely on the model data customer, then if Magento 2 decided to update one of the methods inside of there, it's our own fault if it breaks, because we're not adhering to the blueprints. And it's so easy to actually use. If we do want to use the customer, we just inject it into our constructor, the customer interface, and we can do it. We can use it. We can say customer, get name, set name, delete, load, whatever we want to do. Even though we're just injecting the interface, because of the preference for that interface is giving us the object back, we can continue to operate quite nicely as long as Magento keeps adhering to that principle. So a bit of a recap on interfaces. I've gone on quite a lot about what an interface is and why we should be using interfaces, but interfaces should never, ever, ever, ever change between major versions. It's inherent to everyone that if we build an interface and a module that we're releasing, that interface shouldn't change between major versions. We should use semantic versioning to push out what it is that we're doing. So as soon as my module's stable, 1.0, keep building 1.0.1, 1.0.2 with bug fixes. Break the interface, 1.2, or maybe 2, depending on how severe a break it is. They are still a work in progress in Magento 2. It's an ever-evolving system. More modules are being given interfaces. So if there is an interface there, make sure you use it. And we should always use dependency injection. So rule being, if there's an interface, inject it. Don't use Object Manager, otherwise Ben Marks and the core team will cry and shout, and I'll cry as well because it's bad practice. The Object Manager is easier to use, but it's a lazier way and hopefully will be deprecated over time. And it generates its own DI container in production. So it may be slower while we're working locally, but when we go into production mode, we compile this ginormous DI class, this big object of how to reconcile each of the individual objects. So it is a must for actually using it in Magento 2 development. If you want to look at any of the source code, however plain it might be, you can find it on my GitHub. And other than that, thank you very much. Any questions? Yo.
I have a question. When working with injecting into constructors, when you're using collections, would you recommend using Refactoring instead of injecting collection, I'm assuming?
Yeah, so the factories are auto-generated PHP class files. So the question was, would we, for a collection, inject the collection itself or rely on the auto-generated class factory that Magento 2 creates? In that instance, if we were calling the product collection, then we should rely on the product factory, which gets auto-generated for us based on the API, and then we can make sure that we are pulling the correct information out.
So in the out-of-stock method, for instance, you would have just called the factory and then sorted the collection or filtered the collection?
Yeah. Really, it should have been the factory, but because I was using the object manager, just go for the product collection direct, which is bad. No. Any more? Cool. Well, thank you very much for your time, guys. It's been a pleasure. Have an enjoyable conference.